Friends, today let us study the cable with ends at different levels. In the previous video, we have studied the supports at same level subjected to UDL. Now, today we will discuss about the ends at different levels subjected to UDL. Here, consider a cable which is supported at A and B. Here A is at a height of, this one is the lowest point, this one is H1, this height is H1. A is H1 meter above the lowest point C and B is H2 meter. This height is H2 meter above C. This is subjected to UDL of W per unit length over the entire span L. Let the horizontal distance between A to C, that one is LH, and the horizontal distance between C to B, that is this distance, that is L2. Horizontal reactions at the support, here this one is horizontal reaction at support B, that equals H. Similarly, this one horizontal reaction component at A, that one equals H. Now, here to find the support reactions, here to study a cable can take only axial force. It is subjected to tension. A cable at any point D, here to find the forces and the length of this one, a cable can resist, can take only axial forces. Axial force, that is, it cannot resist or it cannot take bending moment. Here the bending moment is 0. Bending moment cannot take bending moment BM and SF. Only it can carry the axial force. Hence, this is the lowest point. Hence, at lowest point C, it is subjected to lowest point C, the axial force equals H, and there is no force in vertical direction. As shown in figure. Here, this one, vertical direction. This one is at any point D. Here, this one is point C. This one is any point D. If you consider this as origin, this one is y-axis, this one as x-axis. Here this is x-axis, this one is y-axis, this point is C, that is the lowest point. Here the forces acting at this point is only axial force H, no vertical force. It is not subjected to any, it will not take any bending moment and shear force. Then here this one is point D. Here at this point, here it is subjected to tensile force T, like this. This one is T. If you resolve this force into two components, one in horizontal direction, one in vertical direction. If this angle is theta, then this one is the horizontal component of T. This one is the vertical component of T, that is tension in the cable, and here this portion is subjected to load over this length. This one is subjected to load of intensity W per unit length. Here this distance between C to D is X. Then at point D, slope is theta. Here this one is the slope. Taking lowest point C as, take lowest point C as origin. Yeah, this one is x-axis, this one is y-axis. And considering the equilibrium of portion, and by considering equilibrium of the portion CD, here I told that if you resolve this, T cos theta equals H. That is horizontal reaction component at day. Then T sin theta equals vertical component, that one equals Vd. Here if you want you can write this one is HD, Vd upward minus due to the applied load W into X. Then by using these two equations, equation 2 by 1, that is equation 2 divided by 1. Here by equating by this, that is equation 2 by 1, we will get tan theta equals, that is Wx by H. Here that one is Wx divided by H. Now dy by dx equals, now you know that in deflection you have studied dy by dx is nothing but tan theta, that one equals Wx by H. Here you have got an equation. Then integrating this equation, that is integrating with respect to x, then integration of this one is W, or we can write one more equation, that is one more step, that one is y equals Wx square divided by 2h plus C1. C1 is the constant of integration. At x equals 0, y equals 0, Therefore, C1 equals 0. Then, this is the equation of a parabola. This is an equation of a parabola. This is an equation of a parabola. Hence, the cable is having cable is having parabolic shape. Yeah, by observing this, that is wx square by 2h is nothing but an equation of a parabola. Y equals, then here y equals wx square divided by 2h, where h is the horizontal reaction. At x equals or y equals h1, then substitute the value of y equals h1. X equals L1. Here we have considered C as origin, lowest point C as origin. Then H1 equals WL1 square divided by 2H. WL1 square by 2H. Similarly, H2 equals WL2 square divided by 2H. WL square divided by 2H. Then H1 by H2 equals WW get cancelled, 2H get cancelled. That is H1 divided by H2, that equals L1 square divided by L2 square. Or L1 by L2 equals root of H1 divided by root of H2. Here by cross multiplication, L1 equals root of H1 divided by root of H2 into L2. By cross multiplication, substitute the value of L1. Then just now we have calculated the value of L1. L1 plus L2 equals L. Then substitute the value of L1, that is L2 root of H1 by H2 plus L2 equals L by L1 plus L2 equals L. Therefore, L2 is common. LCM is root of H1 plus root of H2 divided by root of H2, that equals L. Then L2 is given by L into root H2 divided by root of H1 plus H2. Similarly, L1 equals L into root of H1 divided by root of h1 plus root of h2. Here now we have calculated the value of L1 and L2. Now to find H, the horizontal reaction component, to find H, that is horizontal reaction component H, taking moments at T, moments at C. Taking moments about the lowest point C from LHS. Here from LHS we have to calculate. Then here by observing this diagram, here VA is VA into H1. That one is clockwise. Minus H into H1, that is horizontal reaction component. That one is anti-clockwise, H into H1. Then due to UDL, that is W into L1 into, that one is also anti-clockwise, minus W L1 square by 2, that one equals 0. Or VA equals, here by simplifying this, VA equals, we will get VA value equals, that is H into H1 plus WL1 square by 2 1 over H1. Here we will get the value of, that is WL1 by VA into L1, not H1. This one equals, that one equals WL1 by 2 plus H1 by H into H1 by L1. Here this is the value of VA. Then if calculated from RHS, then now we have calculated from LHS, we have got the value of VA. Then if calculated from RHS, that is PB equals, by taking moments of all the forces from the right side, or RHS, that give us PB equals, that is WL2 by 2 WL2 by 2 plus H2 by L2 into H. Here this one is equation number 2. By equilibrium equation, adding 1 and 2, equation 1 and 2, we will get, that is VA plus VB equals W by 2 L1 plus L2 plus H H1 by L1 plus H2 by L2. H2 by L2. Then here this equals L1 plus L2 equals L WL by 2 plus H1 by L1 plus H2 by L2 in the bracket, that is H. But VA plus VB equals, by one of the equilibrium equation, total upward forces equals total downward force. Then that gives us WL equals WL by 2 in the bracket H1 by L1 plus H2 by L2. Then this one is WL by 2 equals H into H1 by L1 plus H2 by L2. Then H equals WL divided by 2 times H1 by L1 plus H2 by L2. This one is the required equation for the value of H. Here, substituting the value of L1 and L2, what we have calculated in the above equation, we have calculated, that is H equals, substitute the value of L1 and L2. L1 and L2. Then H equals WL by 2 divided by H1. L1 is L1 we have calculated, that is L into root of H1 plus H2 divided by L into root H1 plus H2 into root H1 plus root H2 divided by L into H2. Then here this equals L is WL square by 2, that divided by here 1 divided by LCM is H1 H2, that is H1 into root of H1 plus root of H2 divided by root H1 plus H2 into, in the bracket, H1 plus H2 divided by root H2. Then if you simplify this, again you will get, that is WL square by 2 H1 divided by root H1, that one is H1 in the bracket root H1 plus root H2 plus H2 divided by root H2, that is root H2 root of H1 plus root H2. Then here this one is WL square divided by 2 root of H1 plus root of H2 whole square. Here this one is an equation to find the horizontal reaction. By equation 1 and 2, by equation 1 and 2, 1 and 2, get phi A and phi B. Phi A and phi B. Okay, we'll continue. To find the length of the cable, the total length of the cable ACB, length of cable ACB, that one equals here half sum of the length of length of ACB dash, length of ACB dash plus half of sum of length of ACB dash and A dash CB. Here we have extended as shown in figure. This one is the figure. Here this one we have extended this curve up to B dash. Here we have made it symmetrical, half of the length of this portion and half of the length of this portion. We have to find the length, that is the total length of the cable is half of 2L1. Just in the previous video we have calculated, that is 2L1 plus 8 H1 square divided by 3 into 2L1. Total length is 2L1 plus 2L2 plus 8 H2 square for second curve 3 times, that is 2L2. Here this one is the total length. Here this equals 2L1 plus 2L2, that is L1 plus L2 is L, 2L divided by 2, that is L, plus 2/3 of 2 to get cancel. This one is 4 by 3. This one is 2/3 of 2/3 of H1 square divided by L1 plus H2 square, 2/3 of H2 square divided by L2. Okay, here this one is the total length of the curve when the levels are at different levels.